Okay, I apologize. Probably the quality of this video may not be wonderful, but let me just keep as best as I can. So this is the continuation from the previous video. As you can see, we already choose A, B, C, and another C here, and we have point D here and an E here. And so we're going to choose the loops, and there will be 3 independent loops could come out. So here is what I'm going to do now. So let's choose loop 1. So this is my step number 1. So I'm going to choose loop. And so I'm going to start with the A. So essentially it will be A, B, C, this is the same C, and a D, and E, and back to A. This is the first loop that I'm going to use. And the second loop, which I will wait a little bit, and it will show you in a minute. So this is what we have so far. And now we're going to move on to the next part. First, we're going to start with the VA. Path through the power supply, so voltage is from negative to positive, it's going to increase to the point B, and suppose my current flow like this direction. I can assume any current that I want in the beginning because they are unknown. So this goes up. Suppose this current, just make a guess, suppose this current go this way. Let's go to I2. And suppose this current maybe go this way, I don't know, I3. So these can be assumed as far as they are unknown. So we started with the A, and now we end up with point B. Because the current go this direction, my loop direction is same, so the voltage is going to drop. So this is minus I1 R1. That's how much the voltage dropped. So now we pass through point A, point C, forgive me. So this C is the same C, so now we're going to go through this part. From here all the way to that. You see the loop direction is opposite to the current, so in other words the voltage is going to be adds. So it's going to be increases by I2 R2. From a positive to negative, that's minus sign, epsilon 2. So we reached point E. Now eventually point E and A is the same thing. So we have V. So this is the equation, first equation. And we, of course, we can cancel these two. You can plug in these numbers now because you are know how large epsilon is, how large epsilon 2 is, and you know R1, R2. So essentially this will be equation like a regular mathematical equation. Let's say 3x plus 5y equals negative 10, like this. So y my x here is just like I1, y here is just my I2. Okay, so that's the first loop. Let's work on loop number 2. So this is the second loop. And you're going to end up with something like this. I'm going to choose a loop. You can choose this loop, smaller ones. It doesn't matter. So we're going to start with E, to D, to C, all the way back over here, and back to E. So I'm choosing this loop. So direction is go like this. So now what I need to do is just start with the VE. So that's my first voltage point. And since I moved from negative to positive, so epsilon should be a positive 1 here. And then next thing that I need to do is once I go from here all the way to that, so the loop direction and the current direction the same, so the voltage drops, so which means minus I2 R2. And eventually I reach over here. Now keep on going from here to there. Remember, loop direction is go this way, so in the same direction as current. Again, the current drops I3, R3. So now we reach the point E, so we get VE. Again, we cancel these out. So now we just have a similar equation. We plug in epsilon 2, R2, R3. So we have equation something like a negative x minus maybe 7y equals 3, like this. Okay. Now the point is that you see you have I2 here, I3. But in this equation, you only have I1, I2. So I do not like this I3. Because if I get rid of this I3, so therefore these two equations only have two unknowns, I1, I2. So this started with my step number 3. Sorry, there's a little shadow because there's no way that I can get over the light. So step number 3, I'm going to do junction rule. The junction rule stays the same, and you choose one junction. It's only junction you can have. So this is the point of C. So now you see current I1 go into it, I2 go into it, I3 comes out. So essentially we will have I1 plus I2. These two currents go into the junction point. We have I3 comes out. So now we have this particular equation. What we want to do before it becomes similar equation like this, we plug this equation into the previous one. So what you end up with was epsilon 2 minus I2 R2 minus, did you see I'm going to replace this I3 by I1 and I2. So this becomes R3 equals 0. Now you can see you want to make sure the coefficient of the I2 combine to each other, which means I2, R2. Remember you have a negative R3, negative R2, so they will be the same R3, I2. So this is I2 minus I1, R3 equals 0. So now eventually you have two equations. Remember this equation comes from here. Equation number 1, equation number 2. I hope you're still being able to read it. And yeah, my cell phone seems to have some issues, but it's okay. Now, so once you end up with this equation, so you will simply look like this equation now, just like a negative x minus 7y equals 3, like this. So now all you need to solve for x, y, or in this case, just I1, I2. Sounds good? Let me stop here, and if you have questions, just let me know. I hope you like it.